There are moments late at night when a parking lot goes quiet enough that even the air feels heavy. Streetlights hum softly above rows of sleeping cars, their reflections stretching across polished paint and dark glass. Then at the far end of the lot, you notice a shape that doesn't quite blend in. Long hood. Wide stance. A roofline that slopes back with the kind of confidence only one name in American performance really owns. The Mustang GT doesn't try to hide what it is. Even standing still, it looks like it's waiting for permission to move. The hood stretches forward like a runway, hinting that something serious lives underneath. And tonight, we're not here for the badge or the history or the stripes people love to argue about. We're here for the heart of it. The engine. Because in an era where turbochargers and hybrid systems are quietly replacing big displacement engines, the Mustang GT still carries something that feels almost rebellious. A naturally aspirated V8. No artificial soundtrack. No complicated boost system masking the experience. Just displacement, metal, and combustion. You reach for the door handle and slide into the driver's seat. The cabin settles around you with that familiar muscle car posture, low, focused, slightly aggressive. Your right hand moves to the start button. For a moment there's silence. The kind of silence that exists right before something mechanical wakes up. Then you press it. The starter motor spins once. And the engine fires with a sharp, explosive bark that immediately fills the night air. Not loud in a chaotic way, but deep. That's like a heavy drumbeat echoing through metal. The idle settles into a steady rhythm that feels alive through the seat and steering wheel. Each combustion pulse moves through the chassis with a faint vibration that reminds you this isn't just transportation. It's machinery. Raw mechanical machinery. Blip the throttle lightly and the revs snap upward with surprising speed, the exhaust tone sharpening into a metallic growl before dropping back into that deep idle. You can hear the breathing of the engine through the intake. A faint rush of air. 8 cylinders waiting for more. And at this point, we haven't even talked about numbers. No horsepower. No torque figures. Because those numbers only tell a small part of the story. What makes this engine interesting is how it's built. How it breathes. How it responds. And why Ford engineers chose to design it the way they did in a world that increasingly rewards smaller engines and forced induction. Under that long hood sits one of the most fascinating modern V8 designs still sold in America. An engine that blends old-school displacement with surprisingly advanced engineering. And once you understand how it works, the Mustang GT starts to make even more sense. So let's open the hood. Because the real story begins inside the engine bay. At the center of the Mustang GT sits Ford's 5.0-liter V8, an engine most enthusiasts know by its legendary name, Coyote. But the nickname only hints at the complexity hiding beneath those valve covers. Architecturally, this engine follows a classic V configuration. 8 cylinders arranged in 2 banks of 4, set at a 90-degree angle. This layout has been the backbone of American performance engines for decades because it naturally balances power delivery with smooth operation. But the Coyote engine isn't just a modern version of an old idea. It's a deeply engineered system built to survive high RPM operation while maintaining everyday drivability. The block itself is constructed from aluminum rather than traditional cast iron. That decision alone removes a significant amount of weight from the front of the car, improving balance and steering response. Inside that aluminum block sits a forged steel crankshaft designed to withstand repeated high-speed rotation under extreme load. The crankshaft converts the vertical motion of the pistons into rotational energy that ultimately drives the wheels. Every time one of the 8 cylinders fires, it pushes a piston downward with explosive force. That motion transfers through connecting rods to the crankshaft, turning combustion into motion. The pistons themselves are lightweight aluminum components designed to survive intense heat while minimizing reciprocating mass. Lower mass allows the engine to spin faster and respond quicker to throttle inputs. And response is something Ford engineers clearly prioritized when developing this V8. Moving upward from the block, the cylinder heads are also aluminum and packed with advanced airflow design. Each bank of cylinders is topped with a dual overhead camshaft configuration. That means 4 camshafts in total controlling the opening and closing of the intake and exhaust valves. Dual overhead cam designs allow engineers to control valve timing more precisely compared to traditional pushrod layouts. And precision is critical in an engine that wants both high RPM power and low RPM drivability. Each cylinder breathes through 4 valves. 2 intake valves and 2 exhaust valves. That totals 32 valves across the entire engine. More valves mean greater airflow potential. And greater airflow means the engine can move more oxygen into the combustion chamber. More oxygen allows more fuel to burn. And more controlled combustion ultimately means more power. But airflow isn't just about valve count. It's also about timing. The Coyote engine uses variable valve timing on both the intake and exhaust camshafts. Ford calls this Ti-VCT, or Twin Independent Variable Cam Timing. This system allows the engine computer to adjust when the valves open and close depending on driving conditions. At low RPM, valve timing can shift to improve efficiency and torque. At high RPM, the system adjusts again to maximize airflow and horsepower. It's essentially giving the engine multiple personalities depending on how the throttle is used. Fuel delivery is handled through a modern direct injection system combined with port injection in many recent versions of the Coyote engine. Direct injection sprays fuel directly into the combustion chamber under extremely high pressure. This allows more precise fuel control and improved combustion efficiency. Port injection, meanwhile, sprays fuel into the intake ports before it enters the cylinders. Using both systems together gives engineers the flexibility to balance power, efficiency, and long-term reliability. Cooling is another critical part of this engine's design. A high-flow coolant system circulates through the block and cylinder heads to control operating temperatures during aggressive driving. Performance engines generate enormous heat during repeated acceleration runs, and thermal stability is essential for durability. Oil circulation is handled by a performance-oriented lubrication system designed to maintain pressure even during hard cornering or rapid acceleration. Because when an engine spins beyond 7,000 revolutions per minute, lubrication becomes just as important as fuel and air. The intake system on the Mustang GT plays a huge role in the character of the engine. A large intake manifold distributes air evenly to each cylinder bank, ensuring consistent airflow under heavy throttle. As engine speed rises, the intake system resonates with a deep mechanical inhale that becomes increasingly pronounced near redline. That sound isn't artificial. It's the physical sound of air rushing into 8 cylinders that are suddenly demanding more oxygen than the calm idle ever suggested. Now let's talk about how all of this feels from behind the wheel. Press the accelerator gently while cruising through city streets and the Mustang GT responds immediately. There's no turbo lag to wait for. No boost pressure building behind the scenes. Just a direct, mechanical response between your foot and the engine's rotation. At low speeds the V8 feels relaxed. Almost patient. But give it more throttle and the character changes quickly. The exhaust note deepens as the engine begins pulling harder through the rev range. By the time you reach the mid-range RPM band, the Mustang GT starts to feel genuinely aggressive. The engine's breathing becomes louder, sharper. The intake roar blends with the exhaust tone to create a layered mechanical soundtrack. And then comes the highway pull. You merge onto an open road at around 50 miles per hour. Press the throttle halfway down. The transmission drops a gear. The engine jumps instantly into a higher RPM range. Suddenly the Mustang surges forward with a smooth but relentless push that keeps building as the speed climbs toward 90 miles per hour. There's no sudden spike like a turbocharged engine might deliver. Instead, the acceleration feels linear and continuous. The faster the engine spins, the harder it pulls. And now we can finally talk about the numbers. Because by this point, the sensation of acceleration already tells you this engine isn't modest. Depending on model year and configuration, the modern Mustang GT's 5.0-liter Coyote V8 produces around 450 to nearly 500 horsepower. Torque typically lands in the low 400 pound-foot range. Those numbers place it firmly in the heart of modern American muscle performance. But numbers alone don't explain why this engine feels special. The magic lies in how it delivers that power. The red line stretches beyond 7,000 RPM in most configurations. For a large displacement V8, that's impressive. Traditional muscle car engines often ran out of breath much earlier. But the Coyote engine continues pulling enthusiastically near the top of the rev range. As the tachometer needle approaches redline, the exhaust tone tightens into a sharper, almost metallic scream layered over the deep V8 foundation. Lift off the throttle and engine braking gently slows the car with a satisfying mechanical resistance. It's the feeling of compression working against motion. Another reminder that this engine is deeply mechanical in its personality. From a performance standpoint, the Mustang GT typically accelerates from 0 to 60 miles per hour in roughly the mid-4-second range depending on transmission and traction conditions. Launch control systems in newer models help manage wheel spin by carefully controlling throttle and ignition timing. Because with this much torque hitting the rear wheels, traction can easily become the limiting factor. Repeated acceleration runs introduce another important topic: heat management. Performance engines can lose power when temperatures climb too high, a condition often referred to as heat soak. Ford engineers designed the Mustang GT's cooling system to resist this problem during aggressive driving. Large radiators, efficient coolant channels, and smart ECU management help maintain stable temperatures even after repeated pulls. The engine computer continuously monitors dozens of parameters including intake air temperature, oil pressure, coolant temperature, and knock detection. If conditions begin moving outside safe limits, the ECU adjusts timing and fueling to protect the engine without dramatically interrupting performance. Reliability is another major consideration for American buyers who might daily drive a Mustang GT rather than keeping it strictly as a weekend car. The Coyote engine has developed a reputation for durability when maintained properly. Routine oil changes with high-quality synthetic oil are essential due to the high RPM capability of the engine. Spark plugs and ignition coils also require periodic inspection, especially for drivers who regularly explore the upper rev range. But overall, this V8 was designed to survive years of spirited driving rather than just occasional bursts of performance. In the competitive landscape of modern muscle cars, the Mustang GT sits among a few clear rivals. The Chevrolet Camaro SS, powered by GM's LT1 V8, approaches performance from a slightly different engineering philosophy using a pushrod layout. Meanwhile, the Dodge Challenger R/T relies on the classic Hemi architecture, emphasizing torque and displacement. Compared to those engines, the Mustang's Coyote V8 feels more eager to rev and more technically complex thanks to its dual overhead cam design and advanced valve timing. Each of these engines delivers its own flavor of American performance. But the Mustang GT's engine stands out for blending traditional V8 character with modern high-revving behavior. And that combination may be exactly why it continues to resonate with enthusiasts across the United States. Because despite changing regulations, evolving technology, and the rapid rise of electrification, there's still something deeply satisfying about an engine that breathes naturally. An engine that responds instantly. An engine that communicates through sound, vibration, and motion rather than digital simulation. The Mustang GT's V8 isn't just powerful. It's expressive. It turns fuel and air into an experience that feels mechanical, physical, and unmistakably alive. And in a world where many engines are becoming quieter and more efficient, that kind of personality is becoming increasingly rare. Which might be exactly why the Mustang GT still matters. Because sometimes the most compelling engineering stories aren't about replacing old ideas. They're about refining them, perfecting them, and reminding us why they worked so well in the first place. If you appreciate engines that combine serious engineering with genuine character, the Mustang GT's Coyote V8 remains one of the most fascinating power plants still available today. And if you enjoy deep dives into engines that define entire categories of performance cars, make sure you're subscribed for more explorations like this.